Okay, we are back live. Hi. Probably should change the stream title a little bit. You know what? Nah, leave it for today. Been doing too much stuff lately. Far too much stuff. We just need to get back to core improvements on Puffer and maybe some applications. I think what we're gonna do today, there are a number of different things. The material science stuff is the most interesting at the moment. I would like to at least get that to a point where we have some sort of interesting demo. That's what we'll do right now. Let me see where we are. Yeah, this is me messing with. Okay. Hey Yannick. Two-player turn-based game. Uh-oh. Uh, have you figured out that the turn-based stuff is a little tricky in Puffer? Most of the time we just like have a scripted opponent play one side. Pure infrastructure problem, mind you. Something I plan on messing with soon. Hard to eval how good, but it kinda works. Gladly take a look at that at some point. I don't remember where we left off with this. I believe I had this like basic material science sim. It's not your turn, your action just doesn't do anything. That is actually a decent way around it for now. Like, of all the dumb solutions, I think that's probably the most reasonable. So good job on that. Okay, so here's a particle sim. We got a bunch of particles buzzing around. This was the model. We trained like a go-to-point model or whatever. The next thing we were going to try to do is actually have these things be evaluated based on specific properties, right? We're trying to model. This is material science stuff. We're hooking up Puffer to a material science sim, and we're going to see if we can steer atoms into useful materials. Kind of funny. I gotta go grab my phone actually, because I think that the guy who I've been chatting with on this will DM to me stuff. 1 second. Okay. Thing that I've been suggested to do. Welcome, builder. Thing I've been suggested to do is to go find the thermal conductivity stuff in lamps. Simple Leonard Jones. Okay. Thermal conductivity is a measure of the propensity of materials to transfer energy by Fourier's law. First method is to set up two thermostat regions, opposite ends of a simulation box. Holding the two regions at different temperatures, thermostating to the hot region, the energy subtracted from the cold region. Huh. About thing I've never seen before. I don't know what that is. There like sample of this somewhere. Trying to see if you have to change the sim in order to measure. Why would I know anything about that? Flux can be calculated from the fluctuation per atom potential. Steady state contrast to the non-equilibrium. Okay, I think this is what we want, right? Because this is steady state. So like we can just calculate this at any given time. The thing is they don't have great API docs as far as I can tell. So I mean Kubo. How do And I don't know if this is going to give me potentially point or what. We'll have to see how this works. Worth playing with a little bit today, though, right? Why do you use Grok among LLMs? Because I don't use LLMs that much, so it really doesn't matter. I really don't need to switch between all the LLMs when they leapfrog each other every other month. As you can see, I'm basically using it to find docs. I should at least check to see if it is here. I don't think it is here. I guess it is kind of just like command level, right? XAMPP's command. Yeah, so it kind of just does execute command strings. Define a computation, calculate the flux vector, contribution of atoms in the specified group. This can be used by itself to measure the heat flux through a set of atoms, or to calculate thermal conductivity. I think this is what we want, is thermal conductivity. We have two body interaction. What is this? Ideas of other computers. Per atom kinetic energy. Per atom potential energy. Per atom strength. Okay. Hi. Where where are you at in the environment? I'm trying to figure out how to compute thermal conductivities. Argon. Probably wasn't the smartest thing for me to do today. I really need to be quite quite fresh for something that's complicated, but at least we'll give this a little bit of time, and if I don't make any progress on this, I'll switch to something today. Okay, so it's pretty much they're just pasting in all these commands. What is this? This is tracked thermal conductivity. This is so far just setting up atoms. Calibration. Equilibrium and calibration. Trying to get an equilibrium state, I believe. Put a bunch of argon atoms. They should put themselves into a state, I suppose. Then compute kinetic P stress flux. JZ. Okay, so this is why they have to do all of this. So this is like a weird. I think Lamps just has a really bizarro interface. The fact that it's parsing string commands like this, it just does not have a proper exposed API, right? Paste this thing in. I'm gonna like just play with this a little bit, I think. Still trying to figure out mentally how this stuff works, right? I should just read this more carefully. Cute ID, group ID, slash flux, style name, AEID, ID of a computer calculates per atom kinetic ID, ID of a computer calculates per atom potential energy, stress ID calculates per atom stress. This will give us per atom results. Okay, so do X, Y, and Z flux vector. So this is going to give you vector field then, right? Which I can then render. Just taking so long. I think that what I want to do, right, is I want to figure out how to evaluate this, render these vectors, then like either maximize this and minimize kinetic energy or like something like that, right? Can you read what the this material scientist sent me again? Eight atoms. Doesn't tell us what type of atoms we're making, right? non-interacting particle. Okay. Want to change this. This is why the atoms weren't interacting at all before. I literally have a comment there that I ignored. And pair coef 1.1. I already have this, right? Up just for the heck of it. Atoms will repel if too close. What we want your C-step sets velocities directly, overriding natural MD evolution. But we need equilibrium dynamics without external. Well, it doesn't understand what I'm trying to do here, right? I'm trying to get them to steer into a state. Function starts from the current velocities, position velocities, equilibrates. That's such a weird word. It's equilibrium and calibrate, right? Liberates. Briefly. Under NVT. Flux. Where's the original? This runs a bunch of steps. I don't know why you would do this. It's a giant block of crap. I don't want to do this. Five order. Yes. I mean, it's actually kind of funny because this gave me the thing that this gave me is like roughly the way that you would typically view simulation. It's not like this is not like an uncommon, unreasonable thing it gave me, but it doesn't make any bloody sense for RL, right? We're not gonna do it the correct traditional way and like just have the RL hard fail, right? We're gonna do it the way that makes sense for RL if the thing we get out of it is at all physically reasonable. Important that we do it this way. Yeah, I also don't need to save the state. My camera frozen. Lovely. Hang on. Maybe I just unplug and replug camera real quick once. Well, that's weird. What's wrong with camera? Nothing here. Okay, well, bizarro. Dang it. Well, I guess my camera is just dead. Unless I find some quick way to fix this. Oh, okay. Well, it's completely messed up, but this will do this, I guess. We'll see if that happens again. Computer's kind of old. Also, Windows is terrible. Alright, what did this thing do? What is it doing here? Partial equilibration. Proxy computation. Okay, this is better. Material scientist time again? Yep. Oh, I forgot to ban that bot. Hang on. I don't understand why I have to manually be computing integrals. What the hell is this? No, I shouldn't have to do this. This is making crap up. Why you don't use LLMs for stuff. They're very stupid. Um, just it's annoying because we don't have good docs around this, right? I guess we have this. What is puffer advantage in PufferLib? It is a strict generalization of generalized advantage estimation in vtrace. Yeah, so they have. So for some stupid reason, this implemented trapezoidal rule manually. Okay, this is fine, right? So this is set up this. Let's add this to our sim. Okay. This is basically from their doc, so this is fine. I actually think this is all kind of fine. On to steering step. Close my window. I want to put this before run 1. I do like here-ish. And here we're going to do run 1. Here you extract kappa. Global thermals. This doesn't make sense to me. Why am I only getting one? Why am I only getting one delta? Get total flux vector. It is not for each of the atoms. Is there not any like reasonable measure I can get per atom out of this? Like, I need some sort of localized metric, right? Like, is it not a vector? Is the thermal conductivity not a vector field that we should just be able to evaluate at each atom? Is that not how it works? Okay, you get a global vector. Evaluated at each position technically. Okay. What this is? This is per atom, and per atom flux contribution. Same as before. This is same as before. And instead of this, do this, right? The thing is, this is not an API, right? The fact that I'm writing C is irrelevant at the moment. It's like janky because this is actually just a wrapper around this like opaque command parser and with strings. Guess we need this for delta flux, right? What time is it over there? It is 1:45. I really should have not chosen to do this today. Like, ever. What are you working on? Material science simulation for reinforcement learning. Trying to get some thermal conductivities evaluated. Okay, so this is fine because this is now this is registered, right? So we don't need any of this stuff anymore, right? Do we? During setup. No, we don't. We literally just need... Okay, so this is better then, because this gives us what we actually need. We don't need all this crap. I did not paste the right thing. So this gives us our J deltas. This is a current norm. Are you going to include thermodynamics, temperature? I'm going to play with more things as I understand what the heck is going on. The initial goal is to just get atoms to steer themselves into a configuration that produces some property we care about, right? Atoms to steer themselves into a thermally conductive configuration or like ablative configuration, something basic like that. See if I can get anything working and we can do stuff from there. I just want to see this do something meaningful. Or delta. This is well set up. Here, oops. Gets us our basic setup. Lamps free. Apparently get allocated for some dumb reason. Yeah, this anymore. And what else? I run command somewhere. Run command needs to go here. Be able to extract after the... Hey Joseph, might be a noob question. Any plans, lead directions on robotics and puffer? Recently moved back to robotics and RL from theory and have been meaning to add something to puffer. Yes, so Right now we are doing low fidelity control of our own. We're doing drones. At some point I will want to do a Degree of Freedom arm. One guy spoke to an SF who may or may not be working on it already. If you post in the Discord, you might be able to find him. But yeah, that's something we would like to do. Have like our own from scratch. Um, let's see. For bindings to existing stuff, if you have robotics background, we have a beta, like very basic mani skill binding I can set up looking at. And it's pretty much just a matter of like, can we actually make Puffer be fast and sane mani skill, even though their sims are not anywhere fast as our Puffer sim. Okay, so let's see if this does anything. JX applying 0 offset to null point. Okay, so this didn't get good somehow. On personal Discord, I can actually find. I have a Twitter DM. Let me find it for you. Somebody that I met in person stuff. Um, I'll link his X. Need me to set up a DM? I can. Yeah, so this thing is null somehow. Not register this. Variable JX. And paste this entire thing in. This is like a weird. Like, this is the thing with using packages that work this way. I have to talk to a material scientist, better one, because like really not written in the way you would want. It's like they say they have a C API, but this is not a C API. This is like a wrapper over their DSL. There's where'd my window go? This right? Why is this a null pointer, though? I suppose that eventually, like, these things get parsed into functions, lamps you can probably just call. Get into it. Need this run 0? That doesn't help. Alright, does anybody know why this thing is messed up? And also, well, I guess it's double precision's probably standard for this stuff, huh? Not that bad. Not that bad, it's double precision, not GPU. Put this in. Variable formula cannot be formula not be invoked. Initialize. How's this make any sense? Did I go mess with him? Let me see if I mess with him real quick.
That has ever lived, ever in the history of programmers. Here's why I like LLMs. The reason I love, hi. Hi, Chunky. Oh, green light. The reason I love LLMs is because it allows me to write code faster. And what this in turn does is it gives me more opportunities to, hey, Joseph, hit that motherfucking button, dude. Hit that request to speak button. Hit it right now. I got 15 minutes. I might be the best programmer that's ever existed in the history of mankind. I might be the best programmer. Oh, hello, Sensei. How's it going? Everyone, click that motherfucker. Everyone, click that follow button right now on Joseph Suarez. Click that follow button as soon as possible. Everyone, click that follow button right now. Click that follow button. Hello.
Hey, I think this works.
Yeah.
I was streaming Material Science Dev, and I saw you have this most bait possible space.
Yeah, it's perfect. It's literally, I'm really good at clickbait. You know how my secret to clickbait, the reason people get so infuriated is because I actually really believe it. And that's what gets people. Like, they know that I'm not me. They know that it's real. Like, that's what really annoys people. Like, you could say something that's not real and people won't take you seriously. But as soon as you really mean it, like I really do think right now at this very moment, I do feel like I'm the best programmer in the world. All thanks to you and your glorious software that I've been copying. It's been very, very helpful, actually.
Well, I'm definitely not the best programmer, and I wrote PufferLib.
No, you're probably close to probably the best programmer ever in the world. You're probably pretty close.
I've met a few people who are very, very good late. It's honestly, it's just that, like, the bar that's set by a lot of the big tech companies, you have to dig for it.
Yeah, it's true. It's true. I mean, like, also, like, being a good programmer isn't necessarily rewarded at like big tech companies. Like, at the end of the day, like the way I define a good programmer is like who's someone who is really good at managing complexity and not making things more complex than they need to. Solving complicated problems with simple solutions that are easy to understand and easy to change. And I think that's not necessarily rewarded, right? If you do things in a simple manner, then you actually become more replaceable, right? Which is actually a good thing for the system overall, but not good for you personally.
Yeah, so this is why you just ignore these dumb incentive structures, because you get nothing done.
Yes, exactly. I've been getting a lot more done after I've left my job, let me tell you, or after I was forcibly removed from my job. I've been getting a lot done. I had my first sim to real success today, by the way, just about like 30 minutes ago.
Solid.
Do you want to know what the last bug was?
Yeah, you had didn't you literally was it like an accelerometer or something that was sideways?
Yeah, my accelerometer was like the wrong orientation.
You know, I've actually
the way I debugged
you could technically make it so that it would still be able to fly that way.
Yeah, I was honestly getting so pissed about like the random like trying to figure out the orientation through the 3 different nodes that was managing. Yeah, I agree. The 3 different nodes I was managing, I seriously considered just adding like domain randomization on like the control stick channels and like letting it figure it out. But what I noticed with so I mean right now I'm using yes, I mean it would actually work too. It actually worked. So my setup right now is I'm doing the simplest. I'm doing the simplest thing possible, which is I have an ESP32 on the device. It's sending back the data over the air to my control system, and that's outputting the control inputs to. I basically hacked a bunch of shit to do this. I mean, it actually works. Like the thing I was like really struggling with, I think yesterday. So before yesterday, I learned all about reward design, where I learned all about reward design, about like the difference between sparse rewards and dense rewards. And I actually like took it to practice. Like I actually like, changed the difference, like dense reward versus sparse reward, negative versus positive. And I had the model do things like suicide to prevent the punishment that was too severe for it. And the thing I realized was my general rule of thumb that I've developed now is give it sparse rewards and modulate the rewards every set of steps, and the set of steps need to be more than the horizon of the long-term short-term network, the long short whatever it's fucking called, it's an awful name. But the recurrent neural network, you need to make the rate at which the rewards are given longer than its horizon, so that you force the neural network to learn how to keep state between different, like, beyond its actual horizon, if that makes sense.
Yeah, there actually, I've had a bunch of people annoyed with that. There are some approximations we make that can potentially mess some stuff up with that with Puffer, but also just the kind of hard for the LSTMs to actually remember that far back. Did you
Yeah, I mean,
did you see the way that I did my dense rewards for the drones?
I've not looked at that. I think you had like episode return increasing over time.
Okay, everyone does dense rewards wrong, and most of the material you're gonna read about it is wrong.
Okay.
It's like dramatically better to do deltas than it is to just do like state based. The state based would be like,
Okay.
1 minus my distance to the goal. But that's a state based reward. You should instead do how much closer am I to my goal this step versus last step. That's a delta of the same information.
Right.
It gives you a much larger dynamic range.
I think I've naturally just.
You cut out.
I think I've naturally ended up doing it like that for my rewards in general. It's like they're always delta based.
Well, that's how we had it originally.
How yeah. Because it's a dead zone in Ottawa, Ontario. Do you know about Ottawa, Ontario? It's a lot like Maryland, which is where you're from. Goonies, where I live.
Where the heck even is
I guess
that? I'm at Alberta. I don't know. You're not going to RLC, right? It's in Canada.
Oh man, I wish I was, dude. I really wish I was. Yeah, it's in Canada. I really do wish I was going. I really need to haul ass on this shit right now, but I think maybe next year I'll come. What I want to do is open source and the RLC in Alberta.
Yeah, RLC is like a really small one. I haven't been to it before, but I like Puffer got accepted, so whatever, I gotta go and present.
That's awesome. Congrats.
It's like so dated at this point because it's 2-0, but whatever.
Yes. Ah!
Yeah. Anyways, cool to see you're getting the thing running on.
I'm in the dead zone.
Yeah. It's cool to see you're getting stuff running on the real hardware, though. I got Finn and Sam doing that on our drone stuff.
Gotta do it. I mean, this is the worst. Okay. Dude, fuck this.
Hey guys, how's it going? You hear me?
Hey, Bet.
Hey, I'm in the car, just heading home from work. Actually, pretty good. Wow, this is pretty incredible. Joseph, got Yassine, Jack audio as always. Probably phones on low battery too.
I saw Yassine here with this complete bait title. So I jumped in to troll him, and then he ended up being nice. So I was like, "All right, we'll be nice."
Oh, he's a real chill guy. So it baited me too because I saw that it says you were in the space. I'm like, what? Joseph would never put a title like that. I know he's really good at programming, but yeah, I was confused, and this is pretty cool.
Wait, did I see Finn in here?
I hope so. Where is Finn?
No, he's gonna see me messing around here instead of helping him with his drone stuff. I don't think he's messaged me yet.
He's probably doing either on a holiday or flying a drone. One of the two.
Wait, did somebody make us lunar lander?
Yeah. You haven't been keeping up on the lunar lander's a real thing. It wasn't landing last time we checked. It was spinning uncontrollably and bouncing crazily.
Yeah, that's solid.
You know what's wrong already?
Well, no, it's a simple end, but I can fix it. Sure.
I remember Rocket Lander. Rocket Lander still. Anyone wants to contribute to PufferLib? Please land the rocket.
Interesting. I was measuring latency between my control system and the feedback from my MPU sensor. I realized that like just adding domain randomization to the delta time is enough for it to learn how to deal with latency.
Yeah, that's kind of what we were going to do as well. So I have this theory that like all of hardware robotics plus RL is being done wrong because everybody's trying to just like model the most accurate thing they possibly can and failing and
Yeah.
making it slow. But you don't need to do
Yes.
that. You just need to randomize the heck out of it and make it fast.
Yes.
Now the problem though, this will work for drones. I think we'll get it to work for 6 Degree of Freedom arms at some point when I get around to either doing that or having a contributor make that sim. It's a hard one, but if anybody wants to take a crack at it, be my guest. Stuff like humanoids will be harder because you kind of actually need to do real physics. But I think that like humanoids are kind of lame anyways, so if we just do arms really well, that'll already be good.
Joseph, how do I get involved? Say I want to contribute.
Okay, yeah, Bet's our resident advertiser here. I try not to advertise on Yaxine's face, but it's all at puffer.ai.
Yeah,
well, Puffer.ai, the best reinforcement learning library in the world. Code that just makes sense and is immediately works out of the box. You can learn by just editing the code, C code, direct double buffering magic. Wow.
Yeah, all right, thank you.
It's true. Otherwise, we didn't say anything to him. He just looked at the file. He literally looked at the one file that does like just about everything, like in a very sane and very concise manner. He just looked at it like, oh my god, this is a revelation.
I mean, like it's actually was pretty difficult to even just find that. I mean, before I found I mean, I didn't know. I haven't trained RL models that much before now. Just playing around with Mujoko and stuff, and I was basically touching Mujoko and like trying to work with that and like jacks and stuff. But I found like when I found PufferLib, like I was able to like make so much faster progress. Like really just having everything in one place and being able to read it and like step through it with a print. And, like,
honestly, the crazy thing is I know exactly how to make it 10 times better as well. Just I'm getting bogged down by all the recent work on, building out other applications, contracts, and stuff like that. But I will be back to doing core dev pretty
soon. So, like, what were you thinking to like increase that? I 100% believe you. I'm looking at like my GPU util and like I'm coming up with ideas like, okay, like probably this could probably be faster here and there. But what are you like planning to do?
I mean, they're kind of two things. One is core algorithms just are not where they need to be yet. There's been so much research done on core algos, but it's all done on really slow ends and really, really dicey experimental setups. So we have to go back to that. There have been some recent pubs that I think have a decent chance of working. So there's that aspect. And then the other big thing is just like can compute MFU and see that the GPUs are nowhere near peak. It's just nobody optimizes for these really small models. There's a lot of infra we have to do to actually get these running at near peak. Like, Puffer could easily be 10 million steps per second. It could probably be 20 million steps per second, right?
Yes.
And then if you can do that, then it's like you're just training on petabytes on one GPU at that point.
I mean, I can't like begin to like, the highest value return. Sorry, my baby's having a conversation with me here. But he's currently trying to eat his foot in the back of my car. The highest value return was like just being able to see your results so quickly back and like being able to run many different experiments. Because at the end of the day, the next experiment that you're going to run depends on the previous experiment that you've already run. So being able to close the development loop, the sequential development loop, is how you make progress. And for me, like I wouldn't have been able to make this progress if I didn't find infrastructure to run these training loops so tight so that I could myself gain the experience, be able to do the things I'm trying to do.
Yeah, well, the dev cycle's got to come down, I think, even more, because right now it's only short for very simple problems. It's still too long for, like, medium complexity problems. There are two things that go to that, though, right? So there's making the thing faster, but also just core algorithm progress also helps. I mean, the problems that we take on now as relatively out of the box required a lot of hand tuning just one version ago. Of course, I actually have to find the time to like sit down and do all that work.
How's contracting going? You making the big bucks now?
We've gotten quite a few leads. I'm pretty much, the goal is to stay in California until we have something sizable signed. Yeah. Like the current contracts are going fine, and we have like plenty of leads for potentially bigger ones. Haven't signed anything yet though.
Remember, man, freedom is the ultimate thing. Okay, without freedom, like the most important thing, like I would rather take like a 75% pay cut to take my freedom because holy moly, this kid. I'm gonna park the car and try to get the sun outside. There we go. Problem solved.
I mean, there's also the aspect, right, of the way of getting more and more people, especially from industry, interested in all these tools, is to show results not just on simple game tasks, right, but also on a bunch of things across various different industries, whether it's robotics, control, or logistics, material science, tons of possible applications. The current thing I'm doing is I'm hooking Puffer up to Lamp's material science sim. I'm trying to get atoms to steer themselves into arrangements that produce specific thermal conductivity patterns.
True.
Designing environments is definitely a skill. Like the more you do it, the better you get. And I feel like it's so generally applicable that I'm somewhat surprised at how well it works.
What was that last part?
Baby strong cat. Gotta go, bros. Gotta figure out these kids' problems.
All right. See you around, man. I'm going to get back to stream.
It was real.
Oh,
All right.
All right. See you on the stream, Joseph.
Yep. Bye. Next scene's funny. Literally just starts a random space while driving from one place to another. All right. So how do we just fix this? No. Handle run 0. After resetting atom position. Doesn't help. Change env. These don't need to be double star. Matter. Isn't it kind of silly that it's built this way? Like, why is this thing parsing commands as strings and producing invalid states and such, right? Just be able to call these things as functions. Like, get errors. They don't run exactly at the spot where they break. Not like set the whole state up and try to run everything. Have no idea what happens. Why it's every single time it's like a big package. There's some decisions. Oh, my bad, something. So, let me see. Is it possible that you use one of your environments instead of let it learn completely? Force it to show how it's doing in time, like after every trust region. Letting it learn. Oh, the easiest way to do that is to just eval different checkpoints. Set the checkpoint frequency. You can set it to checkpoint very frequently. Then you can just run eval on a bunch of different checkpoints to kind of see how the behaviors change. The API thing is broken. Yeah. I kind of just want to get something basic running on this, and then I can chat with Material Scientist about if there's a better thing we can use. It's also possible that I can go into the LAMPS internals and just, like, find these functions, but it's not really part of how it's supposed to work. The reset thing? What's this? Okay. Can I just do this? No, we can't. For initialization by a run. How the heck is that a thing? Unless JX Atom. It's supposed to just make all these. Working on my thesis had this question, so checkpoints a set amount of steps, so I can set it. It's a set amount of steps, but it is configurable. You can change it in the config. Heck is this, man? Why does it work this way? It's like very difficult for me to even figure out how I'm supposed to be thinking about this. It's so wonky. It's like this domain-specific language where you kind of set up all these commands, and then it's supposed to just run and populate variables. But, when it breaks, there's nothing to debug because it's just like this massive command block. No trace. Like, are you just supposed to run it for more of these? No, you're not. Maybe, can I just Google this? Not understanding this. Yeah, this package, like, it makes it very, very difficult to figure out what's going on with the way it's structured. The double stuff is irrelevant. Reset. This just need to be... I doubt this doesn't do anything, right? This is a handle as well. Yeah, this is not... Just kind of, like, it's kind of just flailing. It doesn't know either, right? JX and I guess technically if this thing is wrong, you're janky. Not that this has to go in a net, right? Yeah, no. How do we even make progress on this? Not doing something ridiculous, right? No. Run 1. Could be. Do I not have to just, like, run the compute command? I, like, haven't run the compute command? Is it that just, like, this doesn't get done by run? Don't get a JX values. They are per atoms, components of a flux vector. So I have the command defined. Look, I have these commands defined up top. This is supposed to be like some approximation to local flux, thermal flux. I have this defined here, whatever the output of this is. I would think this is supposed to just run whenever you call run, right? It just defines, just does everything in your graph, or no? Or do I have to, like, manually invoke these somehow? Also, so much stuff in here. A lot of just stuff. Package. Big C++ package that doesn't have interface for it. Not just this script thing. Kind of a mess. Yes. Set up before a run. Need to manually invoke after any modification or extracting the courses initialization and evaluation. Okay, this run, so you're supposed to do this. Helping. Right, this is not helping. There's no, like, technically possible happening on the first iteration. Can I get a shorter form of this error? No, so it's not even in the list of error messages. Actually, just kind of a mess. Well, there's no point in me just kind of staring at this for the rest of the day. I guess if this string is wrong, maybe it breaks. Could that be it, that this string is wrong and then it just breaks? It doesn't tell you. Silently fails. I doubt this does anything. I think this is just it flailing. Yeah, see, this is just it flailing and being stupid. Okay. Piss off. Go do a little jig and then run a 50K and then go do 2,000 push-ups if you're... Oh no. Guess you can't. The technical stream, my guy. Scroll elsewhere. Okay. Have a block. Uh, I don't know what the heck to do with this. Really don't. It probably has the source of this thing right, that it's not actually running the command. But then its fix was dumb, right? Hey Joseph, how does pitch and Puffer? It's going fairly well. It's just a lot of time away from other stuff. So like when I actually sit down to write code, I'm basically giga fried. And then stuff like this actually requires a fair bit of thought. So it's pretty tough to make progress on all the things at the same time. Okay. Well, I'm not going to make any progress on more on this. I'm going to have to either back fresh or talk to the science guy or something. Let me think what other stuff I can do, like actually do today. Been like out in SF like 9 or 10 or 5 days in the past week. There are probe ends. There are potentially contributed ends like that. I guess let me just take a quick look at the paper I've been wanting to take a look at. We can a little bit now. It's just published. See if this is any good. Centralized policy. And then this random is that at some. Hope this question makes sense. Okay, so they're going for right. Kind of, I guess. Yeah, this one step, but this is not what we use. This is also not even used correctly in off-ball. Oh, hey, Finn. I don't know. I've been doing too much stuff this past week. Tough for me to really get into anything super heavy at the moment. My mind's kind of super scattered. How's the drone stuff going, though? I got it to the point where, like, we have pretty dang good policies on the drones. We have, like, pretty dang good policies on the drones for swarming and pretty dang good policies for racing. I couldn't get it to work at the same time, but we have two policies and they're both pretty good, and they're in the same sim. Aiming to have sim to real working next like 2. Okay, awesome. Yeah, like, let me know what you guys need for me to help with that stuff. I can technically get myself a drone kit out to here. I'm going to be at RLC for a little bit, obvious. I definitely want to see Puffer working on real hardware. There are a bunch of sort of similar projects around this space that we can do if this works as well. I've had a couple inquiries from drone people as well. Is this Monte Carlo? Oh, hang on. Yeah, this is a bad diagram. But then they have separate stuff, don't they? The results. Okay, so they're comparing to just PPO. They actually have as competitive with SAC. About what we would expect. What the heck is this? Oh, they actually screw up here, don't they? Works here. Hard fails here. Practically doesn't do it. This is actually kind of reasonable. Motivating thing at the top doesn't make any sense, but maybe I can look a little bit at the math and just see if I have any understanding. If not, we'll just do short stream today and try to come back fresh tomorrow or something. Function. What is this? Scale distance. To look at it. Yeah. Kind of too burnt to like fully do this today, Spencer, but like so this motivation thing at the top, this is garbage evidence. But then the experiments are good. What is this? Okay, these are okay. Action. Not tripping, but question on multi. Do I set action space to negative and find them? Smaller space. Question on multi. Do I set actions? What are you trying to do different? I think you can do it that way, or you can, or I believe if you set like tighter bounds, then it I believe we have clipping in there somewhere. Double check for you. See here. Wrong eval. Yeah, so right here, if you set a tighter space, it should clip for you. Oh wait, self-prediction auxiliary task. Latent self. So this is actually the thing that we've been wanting to do. Like exactly. Set multiple box. You can set the mins and maxes in the box to be a vector, Spencer. Doesn't have to be one number. Getting interested in hyperparameter tuning on the fly. I don't really know if that makes any sense, Finn. Like, you can technically look at something like PBT, but pretty much, as far as I know, all the stuff in that space is pretty janky. They have ablations. Okay, so full auxiliary loss. Does better without an auxiliary loss. Okay, so they do actually kind of have ablations. Yeah, it turns out the auxiliary loss looks like the least important thing here, right? Hey, I hope you're doing well. Loved your tweet, RL, by implementing game M's and their advice. Yeah, it would be my guide. I put all of my advice for newcomers. I pretty much have a step-by-step. Heck is this? Ad bot, great. All my best advice is right here. Link it. Where you go to learn stuff. They say whatever this is, and this is a big thing, right? And no KL is just like, that's trolling, because that's like the core thing. Go. That's this thing here, right? Oh, is this here? This is entropy. Wait. Average policy entropy for KL. Here's Q. This is entropy, right? Is KL, okay. The clipped variant, okay. Ah, okay, hang on. Move the mean squared error and the critic update with a cross entropy based loss function. If you're still here, Spencer, this is a good thing to just try on its own. Yeah, from this paper. This is something I've been wanting to play with for a while. It's just a classification-based loss. Yeah, this seems like this is good. Results on a ton of different things. Very clear cut. Makes intuitive sense. Lines with everything else I've seen in Lit. Up to you if you want to do algo side work. This is what I would probably try first from repo. I try this first. If not, I will get to it, but not today. Brain cells left. Pulse incline end. Yeah, that's good. I got a few more messages as well to look at for us on that side. I gotta say though, just the number of meetings I've done lately, it basically just completely fries me to the point where I can't do any useful technical. Kind of ridiculous. Well, no, it's like I can do it, bet. It's just that I kind of have to go do all of one thing, take a break, and then do all the other thing. I can't just like swap in and out stuff throughout my day easily. I am not autistic. I'm perfectly fine at the perfectly fine with this social stuff. Burns the heck out of me. Like, honestly, the meeting side of things is way easier. Not hard work, and I can put way more hours into it. But, problem is it's all... You actually have to build this stuff. Sounds good, Spencer. What do they mean by no KL? Just no clipping or whatever? Yeah, okay, so that's fine. But then, let me just see their stuff. I want to see if this paper is trolling or not. Clone Spencer. Okay, so look at this. So pretty much, the vast majority of the performance increment comes from this HL Gauss thing. And like, our PPO is significantly better than baseline PPO. Like, I wouldn't be surprised if this is where all the perf comes from. Yeah, this is probably on the algo side. Like, for a relatively simple change, this is probably the highest value thing for us to look at. Now, this doesn't fix our problems. We actually do need to be able to do off-pol. But this is probably highest value thing right now in RL. Anybody watching is can feel free to take a stab at it. Very easy to verify whether you have it working or not. It's just, does this thing do better on most or all of our ends out of the box? The final say on manage. What even is that question, man? What is the question? Overwritten? Oh, that was just temp variable thing, man. No, there was a question about advantage, but it wasn't that. Uh-oh. Wait, what is this? Default networks and propagate the gradient through. Oh, this is bullshit. Hang on, this paper is bullshit. Yeah, this is a weak-tuned baseline classic. Send this to Spencer. I missed this paragraph before. Yeah, very minor. Oh, computing advantage twice. Yeah, so the reason for that bet is that we computed at the start and then we recomputed across all of the samples after every update, because as soon as you update the policy, all the advantages can change. Why we have a CUDA kernel to make sure that's fast. Norm is worse. Layer norm. Literally less than layer norm. How will Puffer handle different algos? Which existing envs need to be factored? No, you don't need to refactor existing envs. It's basically, Tim, we try different algos dev branches, and then if an algorithm is just better across the board, that becomes the new algorithm. The Puffer is not going to be a library of a bunch of different algorithms. Do a research. Like, we try to have very high confidence. We have the best current algorithm overall. On policy. On policy wouldn't really apply as a term here, but sort of yes. Well, this is kind of funny. Where's layer norm? They release code. But did they really not release code? No, they do have it. Okay, good. Oh, they have HL Gauss in here. Wait, what? Importing their own file. Binding? Heck? Bloody sense. Get that guy's in. I still haven't looked at that algorithm. Where's their network? Where's their network? Sure? No. Wish. Garbage. Separate network. A whole bunch of noise. Fine. Wishes. May or may not help anything. Why does it say without and hyperparameter tuning? Alright, well, we found the skeletons in the closet. How feasible do you think having Puffer learn by sight would be? So yeah, I know Hydra's garbage. But you can absolutely do Puffer on pixels lower because pixels are slower. All. There's nothing fundamental preventing you from pixels. You have bindings for pixel, just slow. Alright, so paper, poorly controlled baseline. To their credit, they did tune go a little bit, but then also like the vast majority of the perf here is, well, no KL isn't like you're gonna do KL obviously. But then the like aside from this, the perf is coming from H Gauss. I don't even think you really need this Q function at all, right? What was the claim of this originally? Okay, so this is not exactly what we need. I think honestly the best thing from this is just we take Gauss. The rest of this is kind of whatever. What else did they do with this? Maximum. I've always thought this was dumb. Minimizes loss of entropy. That's not clear though, right? It's like a robotics thing. Couldn't you get some kind of hardware that somehow captures visual? Yes. Can. Not an RL problem to do that though. Estimation. What is this over? Expectation? Just discounted rewards? I don't know why putting this in here does anything. Entropy as an exploration mechanism is very stupid. How do you find these cool papers? Because I have enough followers on Twitter that people just send them to me from here. This is also research. Okay, so if we don't have much faith in maximum entropy RL, what else is this? Bounded entropy. Bounded entropy is sketchy to me. Okay, honestly, like, I think that the most likely outcome of this paper is just use HL Gauss, and that's kind of it. Possibly fiddle with layer norm, though layer norm sucks. But more than anything, this. Also, the other nice thing from this paper is this auxiliary loss sometimes does something, but sometimes not really. Auxiliary loss is not, like, this self-supervised objective is not the magic bullet, it seems. At least not this formulation of it. Well, I mean, this was relatively productive, right? Because I think of everything I've seen, this is like the bit that I have the highest confidence actually does something. Honestly. Of everything I've seen. Now, apparently there is a little bit of a tricky thing with getting Gaussian samples to be fast in Torch or whatever, but this is definitely worth doing here. I don't know about the rest of this paper. It really doesn't even do all the stuff that we would want anyways. I guess it does get you a Q function that's stable, right? A Q function based formulation that's stable. Accent RL's kind of. Time is it? Is it 3:20? Alright. So I think I'm just gonna call it for now, frankly. Is there anything else I can do? Better to just call it and do other stuff for a bit today. Material science sim bothers me that I haven't been able to get something working on this yet, but like, Probably just gonna commit this and send science friend if he can see what I've done wrong with it. All right, well, thank you, folks. I will try to be back fresh. Sometimes in the next few days to actually get some cool stuff done, either implementing this or doing some probe environments or any number of other things. So for folks who are watching, Puffer.ai for all the things, or the GitHub to help us out. It's free. The Discord, get involved with Dev, and other than that, you can follow me on X for more RL.